to continue to solve and compound inequalities. So go ahead and get the x isolated in both of these inequalities. Over here, we're going to go ahead and subtract 4 from both sides. And then we're going to divide by -2. And when we divide by a negative, we flip the symbol right here to go the other way. Divide by 5 here. We do not need to flip the symbol because we did not divide by a negative. So we're going to go ahead and make a rough draft. We're going to start with 2 on the left and 3 to the right because it's larger. And we're going to read this inequality. It says that 2 is less, so we're going to shade the left side of 2. We're going to use a parenthesis because it does not include 2. Doesn't have the line underneath here. And then here it says shade all the numbers that are greater than or equal to, so that's how we know to use a bracket there, 3. So we're going to use a bracket. Whoops, should go the other way. Any number that is greater than or equal to 3. Okay, so now that we have both of them graphed, we look in between the inequalities and it had the word and. That means we want the solutions that work for both. So if we look at our rough draft, there is no shading that intersects. So our solution's going to be no solution. There are no numbers that if you plug them in will work for the same number, work for both of these problems. Because all of these numbers work for this inequality and all of these numbers work only for this inequality. They don't share any x values. So you can write no solution. You could also say empty set. Or the symbol would look like that. So that means your graph would be empty. Don't shade anything. Just leave it alone. And there would be no interval notation. You would just say no solution. All right, go ahead and get the x's isolated on example 4. Pause the video and then push play, and I will have my work to see if you did it correctly. Okay, oftentimes when you're solving over here, students will ask me why we don't switch the sign. It's because this number right here that we divided by was not negative. This was negative, but that doesn't matter. It's whether this number is negative. So we didn't switch the sign in either of these. So now we're going to go ahead and make our rough draft. I'm going to start with the smaller number, which is -2. And we're going to put 3 over here. And this says that I need to shade all the numbers that are greater than or equal to, so that's how I know I need a bracket, then -2. So greater than or equal to -2, so that would be all of these numbers. And then over here it says shade all the numbers that are on the left, so that are less than or equal to 3. So that would be a bracket because it has the line underneath here. And then all the numbers less than are over here. Okay, so once you've graphed both inequalities on the same rough draft, then you look in between, and the original problem had the word and. When it has that word and, you're looking where both the solutions are. So that would be just in the middle here. That's where both of the shading, the intersection occurs. So that means we need -2, including, because there's a bracket there, so there's shading there, that means, all the way to 3. So everything in between and including. So from the left to the right, that's how we write our interval notation. The next problem is also a compound inequality. It's just written a little bit differently. So when you have a problem that looks like this where the inequality are both open to the right and you have something in between like this, it's going to indicate that it is an and inequality. So I'm going to show you two different ways to do this problem. So think of this, there's two inequalities. So this is a problem right here, just like this. So if you chop that off, and then if you chop that side off, this is the other inequality with the word and in between. So this is the same problem as that. So if this looks confusing to you, you can separate it. Again, chop off the left, chop off the right, and solve them both separately. That's one way to do it. The fastest, quickest way to do it is cover this up with your finger so you're not looking at it and solve this like a regular inequality. So we would first subtract 3 to get 4x by itself. But we have two sides, so we have to do it over here. I just realized that my numbers here were different than the ones in your packet, so I just fixed it there. So let's go ahead and continue. So then the last step to solve this inequality would be to divide by 4. Well, we also have this side to divide by 4. Okay, so now if we solve them separately, we would get the exact same thing. If that just looks easier for you to do, you can do it that way. So now to graph this, it's saying everything, just like the x's in between, we need to shade everything in between -3 and 2. Now, if you want to know why that is, and we did a rough draft, if we split this up, this is saying shade all the numbers that are bigger than or equal to -3. So all the numbers bigger than or equal to -3 are over here. And then this one is saying to shade all the numbers that are less or equal to 2. So again, it's in between. So it will always be like that when the inequality starts this way where the x is in the middle. It means everything in between -3 and 2 in this case. All right, last example here. Go ahead and pause the video and solve both of these inequalities. Push play when you're ready and see if our inequalities match. I'm going to go ahead and combine like terms here. Subtract 4. And then lastly, divide both sides by 2. And we get x is greater than 4. Over here, we're going to start by adding 1 to both sides. Here, we're dividing by a negative. So we're going to go ahead and switch the direction of the sign. We're going to go ahead and make a rough draft. I'm going to start with 2 because it's smaller, and a number line goes least or small to big in the order of numbers. Okay, so this says shade all the numbers that are bigger than or equal to 2. So that would be all of these numbers here. Okay, then here it says shade all the numbers that are bigger than 4. We're going to use a parenthesis. Then we go back to the original problem and it has the word and. So that means we're looking for where the shading occurs for both. And that would be right here. So we're going to start with the red and the black. Both start here. So from 4 and everything greater than 4. So not including 4 because there's a parenthesis there. So anything bigger than 4 would work and be a solution to both of the original inequalities.